Okay, let's dive in. Today we're looking at a pretty interesting sequence from the OEIS A000373. Now, for you familiar with the encyclopedia, this one lists the conjectured dimension of a module, and it's tied to a specific algebraic structure.
That's right. It's associated with the free commutative Moufang loop, or CML, with no generators.
A Moufang loop.
Right.
So maybe quickly, what is that exactly? Is it like a group?
It's close, yeah. Think of it like a group mostly, but there's one really critical difference. It's non-associative.
Okay. So 6 times 7 times 6 times isn't necessarily the same as 16 times EL7.
Exactly. You can't just shuffle the parentheses around like you normally would.
But it is commutative, 60 times.
Yes, that part holds. Sum size always equals in a CML.
Got it. So where does this sequence, A000373, come into play? What's the dimension connection?
Well, it traces back to a fundamental question posed by Yuminin quite some time ago. He asked about the order, the size, if you will, of the free CML of exponent 3. And that order is defined as 3 raised to some power, an exponent we call delta. So 1 molar equal 3 delta.
And that exponent, delta n, is the dimension listed in A000373.
Precisely. For these particular structures, it's been shown that the dimension of this associated module is exactly that exponent. So finding delta 10 has been the main goal here.
And for a while, it seemed like we had it right. I remember J.D.H. Smith proposed a formula back in '82.
That's correct. Smith's formula generated the values you see in A000373, at least the initial ones. So, for example, using his formula, a delta 10 came out as 1007.
1007. So people thought the sequence was basically solved.
For a time, yes. But that certainty, it rested entirely on a key assumption, something called the triple argument hypothesis, or TAH.
The TAH.
Yeah.
What did that assume?
Fundamentally, it constrained how certain combinations of 3 elements interacted within the loop. It basically simplified the structure quite a bit, especially as the number of generators got larger.
Okay, but simplifying assumptions can sometimes be, well, wrong. Did the TAH hold up?
And that's where the story takes a sharp turn. No, it didn't. In 2011, Grishkov and Shestakov proved the TAH actually fails once you get to 1 Anton-Evans n-ater or higher.
Wow, okay. So for 1 down in Natal 77, that foundational assumption just collapsed.
Exactly. And that discovery completely changed the status of the sequence for those higher terms. What was thought to be known became purely conjectural again.
That's quite a shakeup. Decades of assuming one thing.
It really highlights how tricky non-associative structures can be. But their work wasn't purely destructive. It did confirm the earlier values.
Oh, good. So the sequence wasn't entirely wrong.
No, not at all. They confirmed that delta 4 and 3, 4 to 299 and 200 2 out of 2. Those results matched Smith's formula and other partial results. So it worked up to 1007.
Okay, so the wheels came off specifically at UNA 377.
Right, and that's where it gets really dramatic. Instead of Smith's on then 7,
yeah.
The true value for delta is now known to be one of 2 specific possibilities. It's either 1014 or 1035.
Whoa. So not 1007, but either 1014 or 1035. Why the uncertainty? Why 2 options?
It all boils down to a single, very complex algebraic identity. It's often just referred to as identity 3 in the papers discussing this.
One identity decides the dimension.
Essentially, yes. The final value for delta depends entirely on whether this specific identity 3 holds true within the free CML on 7 generator.
Okay, so what are the implications?
Well, if identity 3 does hold true, then the dimension is the smaller value, delta 7, 12th of 14. And what's quite neat about that possibility is that 1014 matches the known dimension of a related structure, the commutative alternative algebra, 7/7 Zollers. It suggests a kind of cleaner relationship.
A smoother fit, maybe?
Yeah.
And if identity 3 doesn't hold?
Then the structure is, let's say, more complex, less constrained, and the dimension jumps up to the larger value, delta 73555.
So the exact size of this fundamental algebraic object hinges on the truth value of just one highly specific 7-variable identity.
It's kind of mind-blowing.
It really is. So
Yeah.
A000373 turns out to be this amazing case study, doesn't it? It went from seemingly known based on a plausible hypothesis to being definitively overturned for higher terms, leaving us with this conditional answer hanging on a single complex algebraic truth.
Absolutely. And I think the really profound takeaway here, especially for you listening, is thinking about how the structure of something fundamental, like this free loop, can pivot entirely on one specialized identity.
It makes you wonder.
Exactly. It raises the question, how many other mathematical structures, ones we think are well understood, might have similar hidden dependencies, conditional truths waiting for just the right, perhaps very complex identity to be tested?
That's definitely something to think about, a fascinating look at how mathematical knowledge evolves.